So
Yes, sir.
let us write here. So what is a given data here is given data. What is a given data? Resistance of the distributor per meter is resistance of the distributor, resistance of the distributor per meter is equal to how much? Is equal to how much? Resistance of the each conductor is 0.05 ohms per conductor. Each conductor means we'll be having both conductors because two-wire distributor is given. No, two-wire distributor and resistance of each conductor is given. So what we have to do? Multiply it by 2. Understood? Now we will write here what is the resistance of the distributor per meter is 2 multiplied by 0.05, yes or no, per kilometer is given, but it is given in 1000 meters. Length of the distributor is given in 1000 meters and each conductor resistance is given in per kilometer. So for that reason divide it with the 1000. Okay, then you get in meters. Then what you get here? Zero point 2 into 0.05. What is 2 into 0.05? Yes, 2 into 0.05. Value will be zero point 0.1. Okay, zero point 0.1, and this divided by 1000 will be 10 power minus 3 ohms. Okay, next, length of the distributor. What is the length of the distributor here? Length of the distributor. Length of the distributor is small l equal to how much? 1000 meters. Next, current loading. Current loading is how much? I is equal to 0.5 ampere per meter. Next, total current supplied by the distributor. Total current supplied by the distributor is nothing but I into L. You have to remember this point. Let me put here 2 star marks. Total current, total current supplied by the distributor. Total current supplied by the distributor. Supplied by the distributor is I into L. What is the value of I? Is 0.5 into what is the length will be 1000 meters. 1000 meters. So 1 point and 1 0 will be get cancelled here. Then we get 500. Okay, 500 is the total current. 500 amperes. Okay. Now total resistance of the distributor will be total resistance of the distributor. Total resistance of the distributor is again small r into L. What is the resistance value we got here? 0.1 into 10 power minus 3. 0.1 into 10 power minus 3 multiplied by what is the value of L? L is 1000 meters. Then this 10 power minus 3 and 1000 will be get cancelled. Then what is the resistance we got here? 0.1 ohms. So this will be the capital I. So let me change the ink here. So this will be the capital I and this will be the capital R. Okay. Next, then what is the maximum voltage drop? He is asking what is the minimum voltage drop means. Let me highlight this. What is the minimum voltage drop? If you don't remember this formula, directly go back to here. What is the minimum voltage drop occurring at the midpoint? Is total voltage minus I into R into L square divided by 8, or else capital I into capital R divided by 8. Remember this formula, okay? So therefore, the minimum voltage drop, therefore, 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 so let me okay. So let me take the value here. Okay. Hope you understood now. Voltage drop occurring at the midpoint is this formula. Understood, students? So thereby, what is the total voltage will be? Total voltage will be, the students, total voltage is feeding from one point. Total voltage is feeding from one point is given by, that implies what is the voltage we have here is 220 volts. 220 volts. 220 volts minus what is the total current I? Total current I is nothing but 500 amperes. What is the total resistance? Is 0.1. Okay, 500 multiplied by 0.1 divided by 8. Congratulations. So what is the resistance we have here? 0.1. Okay. Now here 1 0 and 1 this 0. Point and 0 will be get cancelled here. Then 220 minus 50 divided by 8. So what is the value we got here? 50 divided by 8. Value will be 6.25. 6.25. 200 by 220 minus 6.25. So that implies 220 minus 6.25. So the value will be 220 minus 6.25. The value will be what? 213.75. 213.75 volts is the minimum voltage. Okay.